Hey everyone, and welcome back. In today's video, we are going to be graphing exponential functions. You know what to do. Go ahead and grab something to write with. Make sure you have your notebook or something to write on because we're actually going to be practicing graphing. And you might even need a calculator today, so have one of those handy just in case. If you need to, go ahead and pause the video and get the supplies ready, especially because I am going to be asking you to turn in your notes from today so you get in that practice. And let's not waste any more time. Let's just get right into it. So the very first function that we're going to graph and talk about today is this function right here, 3 to the x plus 1 minus 5. What we're going to do is graph the function and list the key features. Key features are over here on the left. We have a blank graph over here, and then we even have steps, 3 simple steps to graphing exponentials. So let's hop in. Looking at this function, f of x is equal to 3 to the x plus 1 minus 5. Two things pop out to me immediately. Two pieces of information pop out to me, and hopefully they're popping out to you as well. Just based on looking at this and not really even having to do anything. The first thing that pops out to me is that I already know my horizontal asymptote. I already know my horizontal asymptote is going to be at y equals negative 5. How do I know that? Well, a horizontal asymptote goes horizontally, not vertically. And horizontally, it crosses the y-axis at some point. And horizontally, a horizontal asymptote can be affected by up and down movement. And up and down movement is represented by a vertical shift up or down. So I know my horizontal asymptote is negative 5 because this parent function has been shifted down 5 units. Something else I know, just based on looking at the function that I have presented to me, is I know that this function is exponential growth. How do I know that this is exponential growth? Well, I see that the base of my function is 3. And when a base is larger than 1, we have growth. And the reason I bring this up is it's just something we can keep in the back of our minds because we know a growth function increases, it grows as x increases. So hopefully I'll use that as a self-checking tool as I actually graph. Now let's actually get into the graphing part because that's just some side information that's helpful, but not necessary when we are graphing exponentials. So we've got our 3 steps on the right. Step 1, plug in x so that the exponent equals 0. Step 2, plug in x so that the exponent equals 1. And 3, sketch the line for the horizontal asymptote. So for this, I like to make a little t-chart, an xy chart, an x or f of x chart. Doesn't matter, all means the same thing. And I need to figure out what x has to be so that the overall exponent is 0. Why do I want that? Well, because anything to the 0 power is 1. It's real easy to figure out. So what plus 1 equals 0? Right? What plus 1 equals 0? Well, that would be negative 1. And if I plug in negative 1, I get 3 to the 0, which is 1, minus 5. 1 minus 5 gives me negative 4. And I have that point at negative 1, negative 2, negative 3, negative 4. And I'm even going to label it negative 1, negative 4. And then I can check off the first step, and I need to figure out step 2, which is plug in any x that we need so that the exponent equals 1 now. So I want this entire exponent, x plus 1, to equal 1. Well, if I let x equal 0, right, 0 plus 1 is 1. And the reason I want it to equal 1 is because anything to the first power is that thing. So 3 to the first power is 3. 3 minus 5 gives me negative 2. So I have the point at 0, negative 2. Here's negative 1, negative 2. Check. And lastly, I need to sketch in the line for my horizontal asymptote. Remember, my horizontal asymptote is at y equals -5. So here's -1, -2, -3, -4, -5. Here's my horizontal asymptote at y equals -5. Make sure, you guys, that you are labeling as much as possible on your graph, especially if you're not using graph paper. It's very important that we're being pretty accurate here. And then our function, remember, it's going to hover really close to our asymptotes, and then it kind of take off, something like this. So remember, we wanted to graph, which we did, got a pretty accurate graph with 2 points and an asymptote. And now we want to give in details about these key features. So it's not really clear exactly where my x-intercept is, although based on this sketch, which could be a good sketch or could be a bad sketch, it looks like it's about 1/2, but you don't want to estimate. We can solve for x-intercepts. So remember, x-intercepts occur when y is equal to 0, the y coordinate, right? The height of this function is 0. So the way we're going to solve that is we're going to set y equal to 0 to find our x-intercepts. Doing so, we will have 0 is equal to 3 to the x plus 1 minus 5. Now, to solve this, I'm going to actually have to go back to my solving properties that we did last week. So I'm going to add 5 to both sides, giving me 5 is equal to 3 to the x plus 1. But remember, I want to solve for that x coordinate. So I'm going to have to take log base 3 of both sides. So I have log base 3 of 5 is equal to log base 3 of 3 to the x plus 1. And of course, logs and exponentials are inverses of each other. So I end up with log base 3 of 5 equals x plus 1. And if I subtract 1 from both sides, I'll get the x coordinate. So log base 3 of 5 minus 1 equals x. Now you might be thinking, hey, that's not a number, but remember, we can use change of base to figure out what this is actually equal to. So using change of base formula means that the base goes on the bottom, changing the base to base 10. So log of 5 divided by log of 3 minus 1 gives us x. And if I grab my handy dandy calculator, remember how I said we might need them today? Enter in log of 5 divided by log of 3, and you get 1.4649, so on and so forth. Subtract 1 from it, and we get about 4649. So x is approximately 0.47. Actually, I rounded that wrong, 46. So x is about 0.46, which makes sense because my graph happens to be pretty accurate. However, if I had kind of a wild hand, it might not have been so accurate. So my x-intercept, although it wasn't clear to see where it was, I'm not just going to guess, I can actually solve for it. So my x-intercept is going to be at about 0.46. Remember, the y-coordinate's 0. My y-intercept is wherever my graph crosses the y-axis. Now, looking at my graph, I can see, heck yeah, it crosses it right here at 0, -2. Whenever x is 0 is where my y-intercept is. So it's actually just this point right here, 0, -2. And you guys want to become comfortable with making sure your x and y intercepts are in points as well. Now, looking at my graph, looking at what I have here, I realize that my domain is going to be all real numbers, meaning that as I go further and further left towards -infinity, I still have a graph. It's just hovering right above my asymptote at -5, right? So my domain is actually starting all the way on the left at -infinity, and it's closer and closer and closer to -5. And as I move forward, my graph continues in the y direction, growing rapidly towards positive infinity. My range, however, depends on the possible y values that I'm allowed to have. And notice that my graph only exists above my horizontal asymptote at y is equal to -5. So my range is going to be everything above y equals -5, since my graph exists above my horizontal asymptote. So my range starts at -5 and continues all the way up to positive infinity because it continues in the upwards direction. And lastly, we need to discuss end behavior. So end behavior says we have to go from left to right, and we say, like, as x goes left, where does my function head? Where's the height of my function going? So as x approaches negative infinity, our function, our y values are going where? And as we're going to the left towards negative infinity, I can see that my graph is hovering, going horizontally at -5. And then I ask myself, what does my graph do on the right? As x approaches positive infinity, that just means on the right. Where's my function going? Since my function is pointing up, on the right, it's still going to point up, which means we're going towards positive infinity. Sometimes you'll see as x approaches negative infinity, f of x approaches -5. But remember, f of x is just another way to represent the letter y, to represent outputs. So they're both actually the same. Cool, first example down. Another one to go. Let's continue on, shall we? So the next example I have for you guys is actually -4 to the x minus 1. Again, we're going to graph this function and list the key features of it. Just like last time, we do know a few things right off the bat. I do know that -1 is the horizontal asymptote. And I know that the base of my function is 4. So I also have exponential growth, which means my function kind of looks like this, since my base is 4. However, something new that we haven't discussed yet is that this negative is in front. And how the negative affects our graphs. It's like a -1 being the a value. That causes a reflection, which means this graph is going to flip over the x-axis, giving me this kind of shape. So that's something new to consider based on what a, h, and k represent. So let's continue on and let's make our little table and graph. Again, remember, we're always wanting to choose the first x value so the exponent equals 0. In this case, there is nothing other than x in the exponent, so I get to plug in just 0. So -4 raised to the 0 power. I'm actually going to plug this in. So I have f of x equals -4 to the x minus 1, because this notation is really important. And when I plug in 0, I get this, -4 to the 0 power minus 1, right? But remember, there's no parentheses. I can't make any assumptions. So I actually am just doing 4 to the 0 power, which is 1, and a negative being multiplied in front. So -1 minus 1 gives me -2. This can be tricky because some people might be assuming this. They might be assuming -4 to the 0 power, which obviously these parentheses aren't there. Cannot make any assumptions unless a set of parentheses is there. So it's just the number 4 raised to the 0 multiplied by -1. Just like how we knew this was a reflection because there was a negative in front of it. So something to be careful of with with negatives and exponentials. Can't make an assumption. Sometimes I even just put a little multiplication sign in between so I remember. Then, remember, we also need to plug in x so that the exponent equals 1. Luckily, there's nothing really exciting going on here, so I get to just plug in the number 1. I will do f of 1 down here is negative 4 to the first power minus 1. Again, remember, 4 to the first is 4 with a negative multiplied in front of it, so negative 4 minus 1 gives us negative 5. Now I'm going to plot these two and then plot my horizontal asymptote. See if it makes sense with the type of problem that I am encountering. So I've got 0, x is 0, y is negative 2 right here. And x is 1, y is negative 5. Negative 1, negative 2, negative 3, negative 4, negative 5. And I also have a horizontal asymptote at y equals negative 1. Since I thought I was going to have a growth problem, but it's reflected, I know that my graph is going to look something like this. It really has no other choice but to approach and get closer and closer and closer to my horizontal asymptote at y equals negative 1. And again, remember, if you don't have points that you can clearly mark on a graph, you should be labeling them for accuracy. So this one is 0, negative 2. This one is 1, negative 5. And this matches with what I thought I was going to get. I thought I was going to get some sort of reflection. It has to approach my asymptote. In this example, my entire graph exists below the asymptote. So since it exists below the asymptote, and the asymptote is below the x-axis, there are no x-intercepts. And it will never cross. I don't even need to solve for it because I can visually see that it will never go up to that x-axis. However, it does have a y-intercept. It's right here at 0, negative 2. Remember, x-intercepts occur when y is 0. Y-intercepts occur when x is 0. We have our horizontal asymptote. Looking at our graph, our domain is going to be all real numbers again, because as we go further and further to the left, further and further towards negative infinity, our graph is just going to continue to hover that horizontal asymptote. And as we go towards the right, it's just going to continue to grow really quickly towards negative infinity. So our domain is negative infinity to positive infinity, all real numbers, but the range has changed. Notice that my graph in the previous example used to exist above the horizontal asymptote, and here my graph exists below the horizontal asymptote. Since it exists below, the smallest number is negative infinity, and my graph exists at negative infinity for where the y is pointing, since it's pointing down, and it's going up to that asymptote. So my range is negative infinity up to my asymptote, which is negative 1. I do have to have an open bracket because it doesn't touch it, it just gets arbitrarily close. And lastly, the end behavior on the left. As x approaches negative infinity, we kind of already talked about it, our function is going to hover closer and closer and closer to that horizontal asymptote. And as x approaches positive infinity, on the right, since my graph is pointing in the negative direction, it's pointing down, my function is going to approach negative infinity. Nice! So this was part 1. Check back. You will have part 2 of 2 more graphs that we are going to accomplish for graphing exponential functions.